We are live. So in this lecture, I want to talk a little. I'm going to talk a little bit about more NumPy arrays and random number generators. And this is kind of one to help you with your homework this week, and also the fact that we're going to use random numbers a lot in this class. I'm a big fan of Monte Carlo. You can actually simulate or ask a lot of different kinds of complex questions using Monte Carlo. And the best way to do this is just showing examples. We're going to do a lot of Monte Carlo throughout the course, so I'll kind of slowly introduce the subject to you. But anyway, in this class, in this lecture, I want to talk about just random number generators and kind of doing logical expressions with NumPy arrays and some of the things we can do with it. So as always, we're going to import NumPy as NP in case we need it. And then from NumPy, so NumPy actually has random number generators in it, but I don't like doing NumPy or np.random whatever the function is. So I'm going to do from NumPy, we're going to import two functions, rand and randint. So I run this, and so just to show you this, so if I run rand, what it's going to do is it's going to come back and generate a random number between 0 and 1. So it's going to be a uniform random number. So the equal probability of picking any number between 0 and 1. I can also do rand of 10. And then I can get back an array. What this is going to return is an array of a bunch of numbers between 0 and 1. So let's just set this equal to a variable. And I'm going to pick maybe 100 random numbers. And what we can do is we can look at statistics. So we could look at the mean. We could look at the standard deviation. These are all methods. We could look at the maximum element, and then we can print the minimum element. These are some of the ones we could do. And so I run it, and the first one's the mean, right? So this is the mean of the 100 random numbers. Here's the standard deviation. Here's the maximum value, and here's the minimum value. I should emphasize that whenever you generate random numbers in a computer program, they're not true random numbers because ultimately there's an algorithm that's generating these random numbers. And if you understand how the algorithm works, and particularly I'll talk later about setting seed values, the sequence of random numbers that are generated becomes deterministic. By deterministic, I mean we exactly know, given one random number, what the next random number will be. Because typically random number generators are iterative algorithms, so it's going to generate a sequence of random numbers. The more times you call it, the more random numbers you're going to generate, but that sequence is specific. All right, so one of the things you can do with statistics is, we can come over here and, we can get better statistics if we use 1,000, but let's do 100,000 random numbers. And this is going to give us a good idea what the statistics are. So our mean, if it's uniform between 0 and 1, we expect the mean to be a half. This is the case. It says the standard deviation is 2.88. I actually don't know what the analytic standard deviation is. The max value, as you can see, it's close to 1, but not including 1. And the minimum value is close to 0 because we're at e to the minus 7. So you can use this to generate statistics, so it's sometimes useful. Another cool thing is we could ask, what's if we take the exponential of these random numbers. So here we're taking the mean of the exponential of a uniform random number, and of course its statistics are going to change based on that. All right. So let me show you another trick. So let's say we have an array of 10, and we're going to print that array. And maybe we want to find the values that are bigger than, let's say a half, right? And so what it's going to do is, here the first one is printing out the array of our 10 random numbers. And then the second question is we're doing a logical expression x. And we're asking, when is x bigger than 0.5? And this logical operation is going to be run element by element. So the first element, 0.75, that's definitely bigger than a half, so that's true. The second one's also bigger than a half, it's true. Third one's true, but the fourth one, right, it's way less than a half, that's going to be false. So we can get kind of an array telling us element by element which elements are bigger than a half, or we could do likewise less than a half. We're going to get different values because we're generating a new random number or an array of random numbers. But what I think is interesting is we can play this trick. We can print x, and then we can ask which elements of x are less than 0.5. And what it's going to do is return back an array where these are the elements that are less than 0.5. So we see the first one, we get this element, that's 0.5. We go along here. Here's our next element that's less than 0.5. And then here's our third element that's 0.5. And we could also do things like what's the values that are bigger than 0.5, right? And here we have 4 of them that are less than 0.5, and here we have 6 of them that are bigger than 5. What doesn't work is we can't mix expressions, so we can't do something like x. Let me comment all this out. It's getting a little bit too messy. Let me comment this. What we can't do is something like, x and, if we want the values between 0.3 and 7, this is going to give us an error. It's going to complain stuff. And the reason why is this is a vector operation where this is element by element. This is also a vector operation where it's element by element. But this is a binary operation. So this AND operator does not work on arrays. And so one strategy to do this, we could say, first of all, we could say, just take a dummy variable. We could take that's equal to x bigger than 0.34 or 3. And then we can ask what values of x are less than 0.7. And this is going to return those ones between 0.3 and 0.7. So here we shorten the array, just pick out the values that are bigger than 0.3 of z. And then that z is going to all have values bigger than 0.3, and then we can do the subset that are also less than 0.7. So that would be one way to do it. The other way we can do is we can just use NumPy's logical AND. So we could do logical AND, and then we could say what values are bigger than 0.3, and then what values are less than 0.7. And that's going to give us those values, and then I could come in here. This is kind of getting a little bit messy, and run it. And in this case, I only have one value. But if I run it again, come back here, I run it again. Now I'm going to have 4 values between 0.3 and 0.7. So this is not specific. These tricks are not specific to random numbers. It's just useful using random numbers to illustrate the principle. So another one that's useful is rand int, and what that's going to do is give me a random number between 0 and if I do 2, this is going to be 0 and 1. So I run it, I get 0. I run it again, I get 1. If I want to do 10, it's going to give me a bunch of random numbers, in this case integer values that start at 0 up to and not including the value 2. Kind of Python indexing. There's also a function random integer it's inclusive, but I typically use random int. I could also do 100, right? And so here we're going to have 100 values between 0 and 1. We could think about this as like flipping coins. So if I set this x, what I could say is, how many heads will I get out of 100 coin flips? And so I could say n is equal to the sum of x, right? So I'm going to sum it, and then I could print n, right? And it says here, if I flip a coin 100 times, I'm going to get 46 heads. I run it again, I'm going to get 49. I run it again, I'll get 48. And you could potentially loop this. So I could say, let me come over here. I could say for I, in range, we could do 10. And then we could shift this over. And so, here we do an experiment where we flip 100 coins, so we get 48 heads, then 54 heads, then 52 heads. And we could start generating the sequence of numbers. We could also, if we wanted to do the mean, right? And so I could do heads is equal to NP0. let me define the number of trials we're going to do. So maybe we're going to do, 100 trials. So I'll do NP zeros of n. I'll do this as n. In each case, I'm going to say, come down here, and I could say head of I is equal to sum of x. So if I run this, nothing's going to happen. Then if I come back here, I can print the head. And this is 100 experiments. And then maybe I want to see what the mean value is. And this we expect to be close to a half, right? So it's 50.17, not exactly, right? Because there's always going to be some variance. But if I start doing 10,000 experiments, it's getting closer and closer to that value. Actually, it's not that different here. Run it again, takes a second. And basically, the mean is around 50, or if we want to be a little bit more exact, we divide it by n to get the probability. And now, wait, what am I doing wrong here? Not the mean. That's, come back here. I'm sorry, getting confusing. Yeah, so it's the mean value of the sum. And if we want to get the mean value, we'd have to actually divide it by 100, all right? Because we're doing 100 coin flips, and now we're getting about 50%. So you can do lots of tricks with this. There's also random number generators for other things. So we could also, from Numpy random, we could import rand normal. And if we were to type rand normal of 10, this is going to give us a bunch of normally distributed or Gaussian distributed random numbers with mean 0 and variance of 1. So to show this, let's take x. We have 10,000 variables, and I could do, I can print x dot mean, and then I can print x dot standard deviation. And you'll see the mean is roughly 0 and the standard deviation is 1. If I want to change the mean, I just add a number to it. So I could do +3, and now the mean is going to be close to 3. And if I want to change the standard deviation, I multiply it by a number. So in this case, 2. And our standard deviation will be roughly 2. If I did 7, it's going to be roughly 7. So lots of tricks you can do to change the distribution of it. Maybe I'll do one extra thing here. So if we, from matplotlib, pyplot, I'll do more on this later. We can, right, getting confused here. So we're going to import it as PLT, run that. And maybe I could do x is np rand normal. Let's do 1,000 variables, and then I can do PLT hist if I want to look at a histogram plot. There's all kinds of different plots you can do. PLT show. And where to rand? I don't need NP rand. And so now I have kind of the histogram here. I can change the number of bins. So right now it's a default number of bins. So let's do 100 bins. And now we start seeing the distribution of those random numbers. If I add a constant to it, right? So if I add 4, it's basically shifting that distribution over the 4. And if I want a wider variance, I could do 5, and now it's going to be spread out. So basically, the axis here is changing. All right. With that, I'll stop. This was just a really quick introduction to random numbers, and also kind of these logical expressions on arrays. These are really useful. They might be useful in some of your homework problems this week, but you can play lots of fancy tricks by kind of pulling out elements that satisfy different logical properties. And with that, I will stop. As always, if you have questions, please post them to the comments or to Piazza. Thank you.